Good morning, Excel Geo. What we're going to start talking about today is volume of prisms and cylinders. So now what makes volume different than surface area? So surface area is the surface that makes your prism. So it's the outside of your prism. So if I was to think, or your cylinder. So if I had a can, the surface area would be the metal that makes the can. If I had a cereal box, it would be the cardboard that makes the cereal box. Volume is going to represent what's inside. So the volume of that soup can will be the liquid that it can hold. The volume of that cereal box will be like the Cheerios that can go inside. So I know this is meant for in class, so discuss with the partner, but I mean, what we're pretty much saying that when we talk about volume, it's what fills up the prisms and the cylinders. So the amount the prisms and the cylinders can hold on the inside. So this is going to be the amount the prisms and cylinders can hold on the inside. Okay, so let's talk about this. Let's say I'm going to do one at a time. So if I look at the volume of a prism, you can use the same formula for both of them. But for the volume of a prism, it's going to be base area times height. So B is the base area, which we already saw that big B being used when we talked about surface area. And height represents the height of the prism. Now, when I talk about a cylinder, it's the same thing. The only thing I can say is that I know the base area will always be pi r squared times h. A cylinder, it will always be a circle, but obviously in a prism, your base changes, so the formula that we input in for B will change. All right, so let's think here. So let's find the volume of the cylinder, okay? So if I found the volume of this cylinder, I would say I'm looking for volume is base area times height. So what is my base area? So if I take a look at this, at this, 7 represents my height. So that is the height of my prism. Okay. Now, if I look at 10 here, if I take a look at this is my base. So I need to find that base area. All right, guys. So I need to find that base area. So to find that base area, it is a circle in this case. So I know I can just say pi r squared h. Now, if I look at that, they gave me the diameter of 10. So for r, I know that my radius will then be 5. So I have pi times 5 squared times the height of 7. Now, I see this is all in feet. So if I look at it, it's 175 pi feet. It's not going to be squared this time. It's going to be cubed. Volume is in units cubed. So when you think of a prism or a cylinder, it's how many cubes we can fit inside as opposed to squares on a surface. Now, I can find the approximation, and that'll be approximately 549.779 feet cubed. Now, if I asked you to leave something in terms of pi, you would give me this answer. If I asked you for an exact answer, you'd give me 175 pi because there's no rounding. If I said it was okay to round, you would give me the second answer of 549.779 feet cubed. Now, our next one is a prism. And if we take a look at this prism, this is a nice rectangular prism, because we have 5, 3, and 7. Now, again, you just pick one as your base area. So in this case, I would say this here is going to be my B. And then if I know that's my B, this is going to be my H. So identify in a rectangular prism what your base is going to be and what your height is going to be. So if I then do B equals base area times height, I know my base area, since it is a rectangle, is 5 times 3, which is 15 inches squared, times the height of 7. 15 times 7 is going to give me 105 inches cubed. And if you really think about that, area is in inches squared. Inches squared times another inches for the height will give me that inches cubed too. Now, down here, we're going to just go over a little rule, okay? So take a look at this. This is an oblique prism. This is an oblique prism. And I want to let you know that there is a principle. Cavallari's principle states, if two solids have the same height and the same cross-section area at every level, then they have the same volume. So what do they mean by that? They mean that since this has a height of 7 and it has the same cross-section area, meaning in this case, the area of our base is the same. We have a 5x3 base. The volume would also be the same. So I can say the volume of this is base area times height, which would be 15 times 7, and it would also be 105 inches cubed. This is all by Cavalari's principle. Now, it will make more sense if you flip the sheet over to the other side. Why does this make sense? Now, I know you guys are not familiar with CDs, but these are CDs. These are 2 stacks of CDs, and they're the same amount of CDs. So they take up the same amount of space. Meaning if I had the same number of CDs in 2 stacks, they'd have the same volume because they fill up the same amount of space. Now, if you look at this, we would say that the same number of CDs fill up the right stack as the oblique stack. So if you up the right stack and the left stack. So that means if you're looking at this visually, your right stack is your oblique one, and your left, you're looking at your left, it's going to be the right prism. So in this case, the same number of CDs fill up the same amount of space. So the same number of CDs have the same volume. And it doesn't matter if this is a right prism and this is an oblique prism. And that's what I wanted you to visually see. And that's pretty much what Cavalari's principle states. So that means if I go here and I want to find the area of this oblique prism, I'm saying, okay, I need base area and height. I need this height. Now, if you have an oblique prism, the height will be on the outside. It will be from a segment from a vertex perpendicular to the plane that contains the opposite base. So if I take a look at this, I need to find the height. Now, I can easily find my base area. My base area would be 6 times 4, which would be 24 inches squared. That's my base area. Now, if I want to find the height, I can say, well, wait a minute. I know this is 13, and this is a prism, so therefore they're parallel, so this is also 13. And if we recall, I have a right triangle. If I see 5 as a leg and 13 as a hypotenuse, I think Pythagorean triple, 5, 12, 13. And by knowing that Pythagorean triple, I can now know that H should be 12. Now, could you use the Pythagorean theorem? Absolutely. But if you remember your Pythagorean triples, it is a shortcut. So therefore, I can say my volume would be base area 24. Now, think about this. I just want to show you why. Base area 24 inches squared times 12 inches. Now, if I multiply that, 24 times 12 is 288. Inches squared times another inches is inches cubed. And that's why we have to be careful with our units there, guys. It's because it's how many cubes can go inside my prism. All right, guys, let's take a look at example 5. Now, the same thing applies with an oblique cylinder, but I gave you something different in this case. I told you the volume and I asked you to find the radius. So you're looking for the radius, but I can find that if I know the height, which I do. There's my height. So I know my height and I need to find, and I know my volume. So if I know my height and my volume, I can find everything else. So I know the volume formula states it's volume equals pi r squared h. So in for V, I can put 225 pi. And then I have pi, I don't know r, but I know h is 9. So I can now solve for r. How can I do that? So what I can do is I can divide both sides by 9 pi. Now, what happens when I divide by 9 pi? The pi's here cancel. The pi's and the 9 cancel on this. And I actually, if I simplify this, I get r squared equals 25. So therefore, I would know my radius would be 5 units. So I just worked backwards to solve that problem. All right. All right, last problem of the day, guys. Example 6 down here. What we have here is a hexagonal prism, and it's a regular hexagonal prism. It says it right here, regular hexagonal prism. So let's label what we know. We know that, I know that AB is 8. I know that CI is 15, and I know that MK, I don't see it, MK, that triangle there, is also 8. So when we want to find the volume, we need to do base area times height. Now, luckily, we know our height already. Our height is nice, and it was given to us. Our height is 15. I didn't want to do that. I don't know why it's not letting me. Our height is 15. That is my height. So now I'm thinking of base area. Now, remember, when we have a regular hexagon, the base area is 1/2 AP. The perimeter in this case is easy to find. The perimeter of your hexagon would just be 8 times 6, which is 48. Excellent. But I need to find A. See, I wasn't given A here. I was given MK, which is a radius of my regular hexagon. So I need to drop an A. So I'm making, remember, the apothem is perpendicular to the side. So if I take a look at that, I have this little triangle of 8. I have that, and I have my A. And what is the length of the other side? Well, it's half the length of the base. So I know in here it's half the length of the base. If that base is 8, I know this is 4. All right? So if I want to find A, I can solve A, and it's going to be, you could use Pythagorean theorem. Fine. You can remember that if you have a hexagon, it breaks into 30, 60, 90s. And if you recall that, up here is 30, down here. So this would be 30. This down here would be 60. And you would know that A would then be 4 root 3. If you used your 30, 60, 90, or you can use Pythagorean theorem. Either way is completely acceptable. So now that I have these values, I can plug this in. I can find my base area. My base area is 1/2 A, which is 4 root 3, times my perimeter, which is 48. And when I simplify that, I'm going to get 96 root 3 as my base area. So now I say, well, okay, now I can find my volume. Well, my volume will be my base area times my height. And my height is going to be 15. And if you put that in your calculator and give me an approximation, which I'm going to write an approximation sign. If I put that in my calculator, it is going to be 2,494.153, and it will be yards cubed. All right. Now, what I would like you guys to do is I would like you to complete the assignment below. All right. Also, look at your calendar, please. I updated when the quiz will be for lateral area, surface area, and volume. Tomorrow, we're still continuing volume because tomorrow we'll be working with the volume of cones and pyramids. I hope you guys have a great day, and I'll talk to you guys soon. Bye.